last class about some important chemical properties of 16th group explained. Okay, their reactivity towards hydrogen, reactivity towards oxygen, reactivity towards halogens. Then some important compounds of 16th group elements. That is, first one is dioxygen. So about dioxygen, preparation methods, some important properties, physical and chemical properties, and uses of dioxygen. Okay, so we know already about dioxygen. Here 46.6% is present by its mass in earth crust. We know. So under the name of compounds, 46.6% exist, and 20.964% by its volume. Available in air, atmospheric air. Okay. Now here the dioxygen, oxygen plus oxygen means atomicity is to two atoms are there. So are the O2 molecule, its atomicity is equals to 2 because in this molecule two atoms are present, diatomic. That's why dioxygen. Each oxygen atomic number is 8. Its electronic configuration we know 1s2, 2s2, 2p4. So here the 2d orbitals are not present. Absence of d orbital, it shows some anomalous peculiar properties. Okay. In its outermost orbit, how many valence electrons are there? 6. Out of 6, here 2 are the paired, remaining 2 are the unpaired. So here the oxygen containing 2 pair and 2 unpaired electrons are there. Its maximum covalency of oxygen is 4 only. Do not excite electrons from 2s or 2p to 2d because there is no d orbital. That's why its maximum covalency is 4. Now here oxidation states here at exhibit -2 because ready to accept 2 electrons, or shows -1, minus of, here the +1 and +2 also exhibits common oxidation states. Now here the oxygen in atmospheric air exists as some isotopic forms. Here some important isotopic forms of oxygen are 3. They are oxygen 8 to 16, oxygen 8 to 17, oxygen 8 to 18 are the 3 important isotopic forms of oxygen. Then here allotropic forms. Allotropic forms of oxygen. Here oxygen, dioxygen and O3 are the 2 important allotropic forms. One atom of an element exists into 2 or more different physical form, that is allotropic forms and isotopic forms. Generally, this is oxygen is a odorless, colorless, harmless gas. There is no effect that is present in atmospheric air. Biologically, it is its importance is more. Afterwards, we'll explain. These are some important points about dioxygen. How to prepare this dioxygen? What are some important properties and some important physical and chemical properties and uses? Then here are oxides of simple oxides of oxygen. then ozone. These are the some important compounds of oxygen. First one is about preparation method. Preparation methods of oxygen, dioxygen. So generally, this dioxygen is prepared by using thermal decomposition of oxides. Thermal decomposition of oxides. Here, catalytic decomposition of first method is here catalytic decomposition of chlorates and nitrates. Chlorates and nitrates. So are the best example are the catalytic decomposition of chlorate, that is potassium chlorate, are the KClO3. On heating with MnO2, manganese dioxide on heating. Are the 2 moles of potassium, this is chlorate. Now on heating it gives 2 KCl potassium chloride salt plus 3 moles of oxygen gas is formed. Now in surface chemistry, about this reaction explained in surface chemistry, that is decomposition of potassium chlorate in the absence of catalyst is very slow reaction. The same chemical reaction, if we can take MnO2 metal oxide as a catalyst, it increases the rate of the reaction. That's why here it is a positive catalyst. Totally here the catalyst is a chemical substance which alters the rate of the reaction. Now which alters means here a positive catalyst. Positive catalyst increase the rate of the reaction. Increases. Negative catalyst decreases. That is alter means changes. Now the manganese dioxide acts as a good catalyst. That's why catalytic decomposition of potassium or the sodium chlorate and nitrates, it gives corresponding byproducts. Salt plus oxygen is produced. Okay. Then second method is here thermal decomposition. Thermal decomposition of metal oxides, some important metal oxides on heating, it gives corresponding oxygen. Like here simple HgO, mercuric oxide. Here 2 moles of mercuric oxide on heating, it gives Hg metal plus oxygen gas is liberated. So metal oxide means mercuric oxide. Here the silver oxide Ag2O, it gives here only one oxygen atom is there, that's why take care of the 2 moles. 2 into 2, 4. That's why 4 Ag plus oxygen gas is liberated. Like here PbO2, like it gives here 2 moles, like 2 PbO, lead monoxide plus oxygen gas is liberated. Or lead red is there, Pb3O4 on heating, it gives 2 moles. Here the 6 PbO plus 3O2 oxygen gas, like simple metallic oxide which are ready to decompose without any catalyst, just on heating only decomposes. That's why there are thermal decomposition of these some metal oxides. Second method. So are the preparation methods of dioxygen by using chlorates and nitrates and by using some important metal oxides. Okay. Then In second year only, that is in 12th standard, that is in second PUC, electrochemistry. In electrochemistry, we'll get electrolysis process. Already in first year, curl-based electrolysis process in organic chemistry, we know. So are the on electrolysis process, electrolysis of water and air, will get corresponding oxygen at respective electrodes. Such a electrolysis process in metallurgy will explain. Just remember one simple chemical reaction, that is electrolysis process of water or air, dry air, gives corresponding oxygen at anode. So at anode and cathode, two are there in electrolysis process. At anode only will get oxygen. For example, your H2O water on electrolysis process. Electrolysis means by passing direct electric current. Now here oxygen gas is liberated and hydrogen gas is liberated. That is at anode, oxygen is liberated. At cathode, hydrogen gas is liberated. These two are easy to separate by using again fractional distillation method. And we know in first year hydrogen and its compounds, there are one of the most important reaction, hydrogen peroxide is there. That hydrogen peroxide also, that is thermal decomposition of H2O2 hydrogen peroxide, it gives corresponding oxygen. Your H2O2 hydrogen peroxide on heating, it gives water plus oxygen gas is liberated. Here take 2 moles, here 2 moles balance, water and oxygen gas. And finally, in large scale, O2 is prepared by using air, atmospheric air. So by using atmospheric air, we can prepare large scale, because the atmospheric air contain already given 20.96% present in atmospheric air. So that atmospheric air contains carbon dioxide, water, moisture, nitrogen gas and oxygen gas. Some other important gases, carbon monoxide, like gases are present in atmospheric air. After removing by different methods like carbon dioxide and water, after removing your carbon dioxide and moisture, water, that atmospheric air contain your nitrogen and oxygen gases. This nitrogen and oxygen already given in the preparation of dinitrogen by using fractional distillation and a liquefaction method. By using a liquefaction and fractional distillation method, we can separate dry nitrogen gas and dry oxygen gas. It boils, boiling point is 77.2 kelvins. Its boiling point is 90 kelvins. So by varying their temperatures, first we can evaporate, easily evaporate, boiling point is 77, easy to separate nitrogen gas. Then after removing complete nitrogen at 77 kelvins, we can easy to separate oxygen, easy to calculate, easy to separate, collect the oxygen and separate the cylinders. By using this atmospheric air, after removing moisture and carbon dioxide, the obtained dry and pure atmospheric air containing nitrogen and oxygen, by fractional distillation and liquefaction, we can separate nitrogen and oxygen. So these are the some important methods to prepare dioxygen. In examination, very simple reactions. So all these are the repeated examples in previous first and second year units. In a second year, we will get this in electrochemistry. Here in first year reaction, decomposition of this hydrogen peroxide, H2O2. Like in 15th group elements, nitrogen preparation method, already it is there, oxygen. Only one or two reactions are new. Remaining everything is repeated examples only. Okay? Next. After preparation of dioxygen, some important properties. Some important properties of oxygen. Properties of oxygen, dioxygen, are physical properties. In physical properties, first one is it is a colorless, odorless, poisonous gas. So it is a colorless, odorless, are the poisonous gas. It is dry gas, pure dry gas. Now here air or this oxygen O2 nearly 3.08 centimeter cube is dissolved in 100 centimeter cube of water, H2O. Solubility means it is soluble in water. How much soluble means? In 100 cm cube of water, this 3.08 centimeter cube of this oxygen is soluble in that. Dissolved oxygen. Yeah, DO is there, dissolved oxygen. In 11th standard in environmental chemistry, there is an important concept, DO, that is biological oxygen demand and chemical oxygen demands are there. That is solubility based. Solubility based. In 100 cm cube of water, 3.08 centimeter cube of oxygen is dissolved, present in that. Dissolved oxygen. That oxygen is required for biological process and chemical process. That is biological oxygen demand and chemical oxygen demand. Generally, here O2 molecule is a diamagnetic according to VB theory, VBT. But according to the MOT molecular orbital theory, here experimentally proved here O2 molecule is a paramagnetic in nature, that is according to MOT molecular orbital theory and experimental analysis. Right now, if they'll ask oxygen is paramagnetic or diamagnetic, means better you mention an objective. Oxide molecule is a paramagnetic in nature. So are the initially before MOT molecular orbital theory in chemical bonding last concept, based on VB theory, valency bond theory, one oxygen molecule leaves a dot structure is like this. One oxygen molecule leaves a dot structure. So here in oxygen molecule, two oxygen atoms are there. We can take like this. This is Lewis dot structure for one oxygen atom, and this is the another oxygen atom Lewis dot structure. One oxygen atom donate one electron to this first oxygen atom. Again, it is donate. It forms one electron pair. Then again, one more electron donated by each oxygen atom. It forms two electron pairs. So it forms here one double bond. Here the two pairs are there. This is completely paired. On each oxygen atom, two lone pairs are there. That's why between oxygen and oxygen there is a double bond. One is sigma, another one is pi bond, and remaining electrons are completely paired. That's why here zero unpaired electrons are present. This is paired, this is paired, this is complete paired, all are paired, and is also paired. There is no unpaired. So there is no unpaired electrons. So that's why, according to VB theory, valency bond theory formation, mutual contribution, mutual sharing, the oxygen molecule containing theoretically, there is no unpaired electron, zero electrons, do not attract it towards the magnetic field. That's why it is a diamagnetic in nature. But right now, according to the experimental analysis, according to the MOT, it is a paramagnetic in nature because in energy level diagram, molecular orbital theory, according to molecular orbital theory, according to energy level diagram, in last 2p energy level diagram, it contains like energy level diagram like this. Now it contains vacant orbital. Here 2 are there. Here also 2 are there. Here like this. This is the complete energy level diagram for oxygen molecule. Now here the lower level 1s and 2s is completed. Now this is the energy level diagram for oxygen molecule. So on the basis of this energy level diagram, once we can observe here, 2 unpaired electrons are there. This is pi star 2px and this is the pi star 2py. In this pi orbital 1 electron unpaired electron, that's why number of unpaired electrons are 2. That's why it is a paramagnetic in nature, attracted towards the magnetic field. Right now, oxygen molecule is a paramagnetic in nature. Don't take as diamagnetic in nature. Experimentally proved, that is. Okay. So these are the some important physical properties of oxygen. Then next, some important chemical properties. Chemical properties of oxygen. Okay. So the oxygen reacts with non-metals. Non-metals reacts with metals except noble metals. So except noble metals means like gold, platinum, like they do not easily affect. So in NCERT book, as an in-text question given, which metal is do not directly attack or directly react with, do not react with oxygen, dioxygen. So are the gold rings or the chains, wherever, whenever we can expose to the atmospheric air, or we can wear as a bracelet or the rings, gold AU or platinum rings. We can expose to the atmospheric air. This atmospheric air contain oxygen. They do not react easily. If it react easily oxidizes, color changes. Whereas in silver is slightly, even though it is noble metal, silver is slightly oxidizes, color shades, color changes. But some metals like iron, like zinc and some other important metals, easy to react with, easy to oxidizes when exposed to the atmospheric air, it gives corresponding oxides. That's why the oxygen react with non-metals like carbon, nitrogen, phosphorus and sulphur like this. And non-metallic compounds. Non-metallic compounds means non-metallic compounds like CH4, SO2, like HCl, some other important non-metallic compounds. So I used to react with oxygen gives corresponding compounds, corresponding oxides. So for example, here the non-metal, very simple reactions for oxygen. Regularly, right from 8th, 9th standard, we are just always in science and chemistry, we are observing some reactions about this oxygen. Here simple with non-metals. With non-metals, here carbon combines with oxygen, it gives carbon dioxide. So the carbon complete combustion reaction takes place. It gives carbon dioxide. Amount of heat is liberated. That is an exothermic reaction. It is direct on heating. Yeah, nitrogen combines with oxygen. It gives nitric oxide or nitrogen dioxide. Variety of oxides of nitrogen explained. Yeah, sulphur combines with oxygen. It gives sulphur dioxide gas. Now here the phosphorus combines with oxide and gives P2, O3 or O5 depending upon the number of oxygen and number of phosphorus atoms in this combination. So are the non-metallic oxides like these are formed from non-metals like carbon, nitrogen, sulfur and phosphorus. Some non-metallic compounds means here the CH4 is completely reacted with the excess amount of oxygen. It gives always carbon dioxide plus water. Amount of it is liberated, exothermic reaction. Not only this methane, any organic compound react with oxygen with the excess amount of oxygen. It gives carbon dioxide and water. These are the main important components. Whereas in case of same combustion reaction with a limited supply, that is a limited supply of oxygen gives carbon plus water is produced. This is the carbon black. That carbon black is used in the preparation of ink, black color ink. In first year, in 11th standard in chemistry hydrocarbons, alkanes unit is there. In that alkanes unit, some important chemical properties of hydrocarbons, alkanes. Combustion reactions are there, complete combustion, partial and catalytic combustion also there. Three important variety cases. If you can use catalyst when organic compound react with oxygen, by using certain catalyst you will get the different organic products. Okay, so are the combustion reactions. It reacts with non-metal and non-metallic compounds. In this unit only, I will give an important chemical reaction, catalytic oxidation of sulfur dioxides to a sulfur trioxide. It gives SO3. Yeah, 2 moles. Yeah, 2 moles. Yeah, V2O5 is a solid. It is a gas. It is a gas. This is called a catalytic oxidation of sulfur dioxide SO2. It is a heterogeneous catalysis reaction. Heterogeneous. Because they are the V2O5 is a solid and these two are gas. They are in different phase. That's why it is a heterogeneous catalysis. So like variety examples are there with non-metals, with non-metallic compounds like these. And also here the HCl react with the oxygen. In the presence of CuCl2, here the 2 moles, here gives here the 2H2O. 2H2O plus Cl2 gas is liberated. 2Cl2 gas is liberated. These are the some important reactions with non-metals, non-metallic compounds. Next one is with metals. So like gold and platinum do not react with oxygen, whereas sodium is to react with oxygen. Calcium is to react with oxygen. Your magnesium is to react with oxygen on heating. It gives Na2O. Here the CaO, MgO like this. 2 moles, 2 moles. Here balance it, will get it. Like 2 moles. These are the some important chemical properties of oxygen. With the non-metals, non-metallic compounds and some metals like sodium, calcium, magnesium and some important oxides. Some important oxides of this sodium, calcium, magnesium with the oxygen. Okay. So these are the some important properties, physical and chemical properties of oxygen. Okay, clear? Observe it. Then uses of oxygen, very, very important, regular uses. Without this gas, we can't survive, biologically very, very important. Dioxygen are uses of oxygen O2. Here, in addition to respiration and combustion, thermal combustion reaction, these are common anywhere. So for combustion purpose and respiration purpose, compulsory oxygen required. For breathing purpose, like oxygen required, dissolved oxygen in blood cells required. Now that dissolved oxygen decreases, it creates some problems in a living system. So in addition to the respiration and combustion part, so many uses are there. Oxidation in oxidation process, chemically. Oxidation process. Particularly industrially to prepare steel, here we can use, by using iron we can use oxygen. Very, very important. Now here to create a thrust, here thrust in rockets, along with hydrogen, that is a liquid hydrogen. This is a liquid state. That liquid hydrogen combines with the oxygen for burning purpose, combustion, to create a good thrust, to create certain amount of energy in rocket. It is used as a fuel. Now in 11th standard in acetylene, we know oxyacetylene flame. So the oxyacetylene flame is used for welding purpose, steel welding purpose we can use. So the means oxygen variety uses are there, like in hospitals, oxygen cylinders required. Like climbers, Himalaya climbers, like, and here the deep sea divers. So the deep sea divers, climbers, and in hospitals, oxygen play an important major key role. While moving towards upward direction nearby Himalayas, here the dissolved oxygen in blood decreases, thinking power decreases, then it creates some problem, that is one important disease created, its name is anoxia. In second year, in solution unit, we will get the same concepts. For example, these are the Himalayas, like here we are moving lower part to the upper part, compulsory such people always carry the oxygen gas cylinders. While moving towards your higher level, upper part, your P decreases, means pressure decreases. In this human system, blood contains some amount of oxygen, that dissolved oxygen, dissolved O2 decreases in that living system or human system. Like when our dissolved oxygen decreases, thinking power decreases, then people cannot think properly. When our moves from lower part to the higher part, because pressure decreases at the higher part, here the dissolved oxygen also decreases in the blood. The disease is called a anoxia. When people are nearby sea, deep sea divers from earth to the lower level, like this is the, like people are moving here, deep sea divers, here also compulsory carry the oxygen cylinder. This is O2 cylinder with helium, that is cylinders, oxygen, and this helium cylinder compulsory should carry this, because here also dissolved oxygen is more, because here pressure increases. When our pressure increases, That oxygen may contain some trace amount of nitrogen, combines with oxygen, it forms a nitro compounds. This nitroxohemoglobin, originally hemoglobin, combines with the oxygen, it forms corresponding blood circulation. Yeah, easy to transport from one part of the system to the another part, easy to carry. When our pressure increase nearby deep sea diverse means pressure increase, nitrogen also dissolves in this oxygen. It forms nitro compounds, cannot react with this. It forms a larger size molecule, cannot transport through the CNS system, central nervous system. That's why people, it creates some, for people, creates some problems. That is called a bends. This is one type of disease. That's why your use of dioxin, variety uses are there. These are some regular popular uses. That's why in your textbook given, better you read all these uses. Okay. So in second year in solutions, again I'll explain about anoxia and Bend's diseases. That is based on solubility of the gas in liquid. Hemoglobin is a liquid, like at a high level and at a low level. Very, very important two cases. Okay. Then after oxygen, preparation methods and some properties and uses of oxygen. Next concept is oxides, simple oxides. Here about simple oxides. After dioxygen, another important concept is simple oxides. Generally, binary compounds of oxygen, when combined with when oxygen combined with other element, combines with other elements are called simple oxides. So are they binary means binary compounds means that compound contain two different atom of elements. In that two, one is compulsory oxygen combined with other elements. Other elements means particularly same group or the different group elements. These simple oxides are generally two types. They are, one is mixed oxides, and second one is simple oxides, mixed and simple oxides. Your mixed oxides means contain it contain two simple oxides. For example, in metallurgy explained to you, one simple example is limonite. That is Fe3O4 limonite. That limonite is the combination of FeO plus Fe2O3. Two simple oxides are there. One is ferrous oxide, another one is ferric oxide. Here another important example, red lead this is, that is Pb3O4, also contain like PbO2 plus 2PbO. These are some important mixed oxide. It contains two simple oxides. Sorry, simple oxides are again classified into four types. There are acidic oxides, basic oxides, amphoteric oxides, these neutral oxides. These are the four important different types of simple oxides. Okay, first one is oxides. When oxygen combines with the other group of elements, it gives corresponding oxides. That oxides may contain two elements, like one is oxygen and another one is other element, either same or a different group. Then it creates some oxide. They are called simple oxide. Heading given under the name of simple oxides. Mainly are the mixed and simple oxides are there. Here the mixed oxides are like this, containing two simple oxides. Two examples are here. And here the simple oxides are again classified into four types: acidic oxides, basic oxides, amphoteric, and amphoteric oxides, and here neutral oxides. What are acidic oxides? Some examples. What are basic oxides? Some examples. What are amphoteric? What are neutral oxides? Very, very important, because in examination, which of the following is an acidic oxide or a basic oxide or amphoteric or neutral oxides? So here I'll explain about so all these important oxides, different oxides: acidic oxides, basic oxides, amphoteric and neutral oxides. Here first one is acidic oxides. So here acidic oxides are the simple oxides. When the simple oxides are dissolved in water, against corresponding acidic solutions. Such oxides are called acidic oxides. We can create the definition like, so here the acidic oxides are the simple oxides. When they are dissolved in water, it creates acidic solution. Simple. For the simple oxides are here carbon dioxide, here nitrogen dioxide, NO2. Given to you in 15th group elements, oxides of nitrogen, 6 or 7 important oxides: dinitrogen oxide, nitric oxide, nitrogen dioxide, nitrogen tetroxide, nitrogen pentoxide, like examples. They are acidic given. So are the highest acidic compound in oxides of nitrogen. Like here SO2 sulphur dioxide, sulphur trioxide, here phosphorus trioxide, phosphorus pentoxide. Like these are the some important simple oxides which are acidic in nature. Why they are acidic in nature means, anyone take here the carbon dioxide when dissolved in water, H2O. Then it gives acidic solution, means it forms H2CO3 is formed. That H2CO3 is called a carbonic acid. That carbonic acid is a acidic in nature, because your H2CO3 ionizes, it gives H plus HCO3 minus 1. This is again decomposed, it gives H plus CO3 minus. Finally, your H2CO3 ionizes, it gives 2H plus CO3 minus. That's why when dissolved in water, it produces H plus ion. That's why this H2CO3 is acidic solution that is obtained from CO2, carbon dioxide. It is a simple oxide, a binary compound. That binary compound produces acidic solution when dissolved in water. Take like SO2 gas also, yeah, SO2 react with the water. gives your H2SO3 sulfurous acid. Your SO3 reacts with the water, it gives fuming of sulfuric acid like look like H2SO4 sulfuric acid. They are the acidic solution, sulfurous and sulfuric. There are some important examples for acidic oxides. The next one is some important basic oxides. So here some basic oxides. And also same definition. Your simple oxides. These are also a simple oxides. When dissolved in water, it creates a basic solution, produce basic solution. The simple basic oxides are like Na2O, or CaO, or MgO, like BaO, like barium oxide, are the simple oxides which are basic in nature. Because when they are dissolved in water, like Na2O dissolved in water, I create a basic solution like NaOH is formed. Aqueous medium, this NaOH, like NaOH in aqueous medium, a dissociated gas, Na plus plus OH minus, it produces OH group. Like CaO react with H2O, it gives CaOH taken twice, calcium hydroxide. Calcium oxide react with water. Like magnesium oxide react with water, it gives magnesium hydroxide, MgOH taken twice. Or your barium oxide react with water, it gives your barium hydroxide, BaOH taken twice. Because barium is +2, oxygen is -2, like Ba +2 and OH minus, by crisscross method will get this BaOH taken twice. These are some acidic oxide, these are some basic oxides. Next one is, third one is your amphoteric oxides. So these amphoteric oxides are the oxides which acts as acids as well as bases, or also we can create as these oxides react with both acids as well as bases. Reacts with acids as well as bases. Some important examples for this, like CrO3, like ZnO, aluminum oxide, Al2O3 are the some important examples for these amphoteric oxides. Chromic oxide, zinc oxide, and aluminum oxides are the some important examples for amphoteric oxide. I'll show some examples, reactivities, how it reacts with acids as well as bases. 2 minutes. Take here one example for this. Your ZnO is an amphoteric oxide. It reacts with HCl hydrochloric acid. It gives ZnCl2 plus water, H2O. The same ZnO reacts with the base NaOH and gives your Na2ZnO2 is formed. Like here Zn means take here the 2 moles. Here take 2 moles. Then here take 4 moles. Balanced it is. Sodium zincate plus water is formed, H2O like. So this zinc oxide react with the acid as well as base. That's why this is acts as amphoteric oxide. Now here the Al2O3 reacts with HCl hydrochloric acid, like here solution like water. Now here take here the 6 moles, here 9 moles, it gives one complex. That complex is here 2 moles are there, AlOH. H2O taken 6, here plus 3, 6 Cl minus ions are formed, here 2 moles. Now same here Al2O3 reacts with NaOH sodium hydroxide, like 6 H2O, it gives here 6 here 2 Na3 AlOH taken 6, one of the most important complex. So here the Al2O3 can react with both HCl as well as NaOH. That's why it acts as a amphoteric in nature. So it acts as, in this case, in this first reaction, whenever it reacts with HCl, it acts as a base. Now it is an acid. Now in this case, it acts as a base, basic solution. Now it acts as a acid. So it acts as both the base as well as acid, also react with the acids as well as bases. That's why they are amphoteric nature. Last, finally, neutral oxides. Here the neutral oxides are the simple oxides which do not react with acids as well as bases. Here a simple example for this is carbon monoxide is a neutral. Now here the dinitrogen oxygen, nitric oxide, water also acts as a neutral oxide. These are the some important neutral oxides which do not react with either acids or the bases. So finally, here oxides, simple oxides and mixed oxides. So simple oxides are classified into 4 types. They are acidic oxide, basic oxides, amphoteric oxides, and neutral oxides. Okay. So remaining in this oxygen, ozone concept is there. Tomorrow I will continue that ozone, preparation method, properties. Then allotropic forms of sulphur and its compounds. Okay, last only 2 topics are there. Take care, read well.